Hello everyone and welcome to section 3.4. Today we're going to be talking about composite transformations. So there's not a lot of notes here. We really got a lot of problems just to practice, but the important thing to know is that a composite transformation is basically taking all the transformations we've learned and piling them together into one type of problem. So it's going to be a series of translations, rotations, and reflections to make up a composition of transformations. So that word composition, hold on, let me finish spelling before I try and talk, because I can't talk and spell. So a composition is, like I said, a composition is just that multitude of transformations happening at once. So you can see in example 1, it says we're going to reflect the triangle and then put it over the x-axis and then translate it. So because we're doing all three of those things, it's considered a composition. So we're going to have to apply all three of those rules to see what happens. So step 1 is going to be me figuring out what my initial points are here. So I have m, n, and p. Looks like n is going to be at -1, 1, 2, 3, 4, 5, 6. So n is at -1, -6. P is at -2, -8. And m is at -1, 2, 3, 4, 5, 6. Looks like -6, -8. So what we're going to do is apply the rules that we've learned for each of these and make our way through. So the first thing is reflect the triangle m and p over the x-axis. Remember, when we reflect over the x-axis, our x stays the same, but our y's switch signs. So I'm going to need to change the sign on all of my y's, which is going to be pretty easy, right? This is going to become a positive, this is going to become a positive, and that's going to become a positive. They were all negative, so they're all going to switch to positives. So this is going to end up here, my p is going to end up here, and my m is 1, 2, 3, 4. And my m is going to end up right there. So there's my reflection over the x-axis. I just did it over the y-axis. Ignore me. What was I doing? That's the y-axis. That was foolish. No, they're going to end up all the way up here. And p is going to be p is there. N is there. Whew. Making mistakes. Making a fool of myself. There we go. That's better. So that's the reflection over that x-axis and switches all my y's from being negative up top to being a positive. The next thing they asked us to do is after we reflect over the x-axis, we're going to apply a translation rule. And the translation rule says move everything right 4, down 5. So I'm going to just take all of my x values and add 4 to them, and take all my y values and subtract 5. And that's going to bring us to our solution. So n is going to be -1 plus 4, so 3. And our positive 6 is going to be -5, so positive 1. My p is going to be -2 plus 4, so I'm going to get positive 2. And positive 8 minus 5, so I'm going to have positive 3. And my m is going to be -6 plus 4, so -2. And my 8 minus 5, so again 3. Those are going to be my final solutions, so I can bring them down. Make sure we put them in the right spots. M was -2, 3. N prime was 3, 1. And P prime was 2, -3, 2, 3. I don't know why, it kind of looks like a negative there. Give that 2, 3. And we can graph that final solution over here. So -2, up 1, 2, 3. 3, 1, 2, 3, 1. And 2, 1, 2, 3. And there is my final triangle after reflecting it and then translating it. So if you take a look at this next one, they said in the next one that they want us to rotate rectangle GHJI 90 degrees counterclockwise, then reflect it over the y-axis. So I know that my rule when reflecting 90 degrees counterclockwise is I know that my x and my y are going to change places. And when it goes counterclockwise, I know that my y's are going to become negatives. So I can take these original points and we can apply this rule to them. So let's find these original points. G, H, J, I. So G is at 1, 2, negative 1. H is at 1, 2, 3, 4, 5, 6, 7, negative 1. J is also at 2, but this time negative 1, 2, 3, 4. And that would mean I is at 7, negative 4. All right, so when I go to apply my first rule says we want to switch the x and the y, and we want to make them, make the y's negative. So my first G, H, J, I change. I'm going to move the negative 1 into the first place and change its sign to a positive 1. My 2 moves to the same, or to the second spot and stays the same. Again, move this negative 1 to the first spot and change its sign. Move the 7 to the y position and keep its sign. Move the negative 4, change the sign. Move the 2, leave the sign. And last, move the 4, change the sign. Move the 7, leave the sign. So let's go ahead and get this first transformation put in there. So I'm going to go over 1 up 2. I'm going to go over 1 up 7. 1, 2, 3, 4, 5. There. I am going to go over 4 up 2. 2, 3, 4. And then over 4 up 7. So there's my new rectangle rotated 90 degrees in the counterclockwise direction. And so the last thing we had to do is we then had to apply a reflection over the y-axis. So remember, when we reflect over the y-axis, it causes one of the signs to change. In this case, the one sign that's going to change is going to be my x. Not like I did on the first one, or like I did on the first one I tried to draw it, right? So we are going to reflect it over the y-axis, meaning our x is going to change signs. And we want to make sure that when we do this, we're applying it to the new points. Sometimes I see people who try to go back to the original points and do it to the original points. No. We already rotated the original points. These are the new points. Now I want to take these and apply the reflection rule over it. So we're going to take these new points and change all the x's to the opposite sign. So you can see all the x's are positive right now, so I'm going to make them all negative. So G is going to become negative 1, H is going to become negative 1, J is going to become negative 4, and I is going to become negative 4. And all my y values stay the same, so 2, 7, 2, 7 stays the exact same. And that looks like my final points. Let's go ahead and try and graph that. Over negative 1 up 2. Over negative 1 up 7. Negative 4 up 2. And negative 4 up 7. And this ends up being my rectangle. I rotated it 90 degrees and then flipped it over the y-axis, putting it in that new position. All right, taking a look at this last transformation. In the last one, ignore the little bent paper. Put it in my book bag, I messed it up. All right, we're gonna reflect the triangle, STU. That's a typo. We're gonna rotate the triangle, STU 90 degrees clockwise. Then we are going to translate it using the new rule, xy becomes x minus 2, y minus 1. So I'm going to start with this rotation. We know that when we rotate something, our x and y switch. It becomes yx. And in the case of it going clockwise 90 degrees, it means my x is going to become negative. So we are going to go ahead and switch those and make the x negative. Let's go ahead and put those points down. I've got STU. S is negative 1, negative 1, 2, 3, 4, 5, 6. Negative 1. Negative 6. T is at 0, negative 3. And U is at 1, 2, 3, negative 1, negative 2, negative 3, negative 4. So 3, negative 4. Okay, so step 1 is we're going to switch them and change their signs. So I'm going to take S, T, U. That's a U, not a V. So the first thing we do is switch them. The negative 6 moves into the X position. The negative 1 moves into the y position, but the 1 moving into the y position, the x value is, original x value is switching signs, so it becomes positive 1. We're going to move the negative 3 into the x position, move the 0 into the y position. 0 can't change to a negative, it doesn't change sign, so it's just going to stay a 0. And last, take the 3 and move it, or sorry, take the -4, move it into the x position. Take the 3 and move it into the y position, and because it was positive, now it's going to be negative. And we can give that thing a nice little graph. So -1, 2, 3, 4, 5, 6, and up 1. -3, 1, 2, 3, 0. And -4, -3, -1, 2, 3, 4, -1, 2, 3. I almost went positive. Because I am a positive person. I almost went positive. There we go. Look at that. So you can see we took this little triangle and just rotated it 90 degrees on that clockwise fashion. It just turned about the paper in that direction. So now we've got to finish it up. The last part is just to apply this translation rule. Translation rules are nice and simple, right? It's to take the x values and subtract 2. Take the y values and subtract 1. And that will give me a final solution. So -6 minus 2 is -8. -3 minus 2 is -5. And -4 minus 2 is -6. And then take the y values and subtract 1. 1 minus 1 is 0. 0 minus 1 is -1. And -3 minus 1 is -4. And let's go ahead and graph that. So -8, 0 is here. And -5, -1 is going to be -1, 2, 3, 4, 5, -1. Right on that triangle. These triangles are going to be really overlapped with each other. And then -6, -4. 1, 2, 3, 4. I'm going to do it in orange actually so it stands out a little bit since they are overlapping. There we go. There we go. So there is our triangle. After rotating it, I shifted it left 2 units and down 1 unit. 1, 2, 1. 1, 2, 1. 1, 2, 1. Yep, I definitely did it correctly. So that is a great way to check it. Make sure you're counting it, make sure that picture lines up correctly. And that should be it. If you have any questions, please let us know. Hopefully you are feeling really confident with transformations because we're almost done. This is the second to last section, so keep up all that hard work. Bye, everyone.